Assalamualaikum, I'm back to my evaluator. My name is Nurul Nazira, a final year student under Dr. Najmah and Madam Fazni. So my title for this project is Toward Copper to Mediated Synthesis of Aurones.
This is my content of my presentation.
Okay, what is flavon? This is the structure of flavon. A flavon is very important because it has high exhibit and structural activity such as anti-inflammation, anti-cancer, and antioxidant. Meanwhile, auron is a derivative of flavon that can be found in plants such as yellow snapdragon flower. In addition, the auron exhibited a strong xanthine oxidase inhibitory activity that could be beneficial for the treatment of gout and hyperuricemia. For the problem statement, firstly, flavon derivatives are not abundant due to limited source of natural product, and most flavon are hydrophobic. Our flavon synthesis process involves multiple steps and a lot of time. So due to a lot of multiple time, it consumes a lot of chemical use in the process. The objective of this study is to produce high yield of auron derivative. Number 2 is to develop an efficient method for synthesizing auron. Number 3 is to purify and isolate auron derivative. And lastly, to identify the synthesis molecule with spectroscopic technique. For the significance of study, number 1 is to produce high derivative of auron, and number 2 is auron has high antioxidant and anti-inflammation effect that useful to treat many diseases. And lastly is to develop new method of synthesizing auron. There are many syntheses can be used to produce an auron. So the first is alumina mediated condensation, where the process involves, as shown in the figure, the compound 36 as the starting material to produce an auron. Next is Claisen-Smith condensation and SN2 substitution. In this synthesis, 2-hydroxyacetophenone, which is 42, undergoes a few processes such as protection and bromination to produce an auron. And the third one is Claisen-Smith condensation and oxidative cyclization, where 2-hydroxyacetophenone and benzaldehyde are used as the starting material to produce an auron. In this project, the methodology is as shown as in the figure. Firstly, the starting material will be refluxed and heated for several hours. Next, the product obtained is being monitored by the TLC chromatography and separated by liquid-liquid extraction. To purify the product will undergo column chromatography and lastly high vacuum. By using this method, 3 reactions was carried out in this project. After being column, there are 2 products produced from the reaction 1. First is compound 40 and compound 40A. This is the FTIR spectrum for the compound 40. From the spectrum, there are 4 functional groups can be obtained in the spectra. First is CH for the aromatic ring, C double bond C for the aromatic ring, C double bond O for the ketone, and C to Br halogen group. Compound 40 was obtained in oil state with 0.55 gram and 32.4% yield. To confirm the structure of compound 40, an MR analysis was carried out. From the proton analysis, there are 3 peaks that can be indicated to the compound 40, which is firstly CH double bond to H at the 7.99 ppm and 7.52 ppm, which shows the existence of the aromatic ring. Second is CH bond to one atom of R at the 4.45 ppm, which shows that at least one bromine atom is bound to the carbon. Thus, it is predicted that the structure of compound 40 was obtained similar as in the methodology. Next, for the carbon NMR spectrum, all the chemical shifts for compound as shown in the spectrum are shown, which confirming the structure of compound 40. After that, the same analysis was carried out to analyze the compound 40A. From the FTIR spectrum, there are 2 peaks of aromatic ring and a peak of ketone in the structure. There are also a peak showing the presence of the bromine group. The compound 40A obtained was also in oil state with the mass 0.4266 gram and 18% of the percent yield. Meanwhile, for the NMR proton analysis, 2 peaks formed at 8.07 ppm and 7.50 to 6.63 ppm to show a benzene ring. Another peak shows at 6.69 ppm shows that the carbon holds 1 hydrogen atom. So it is predicted that there are 2 bromine at the carbon. Thus, the structure compound of 40A was predicted to be not same as the methodology. For the carbon NMR spectrum, all the chemical shift confirm the new structure of compound 40, which named as compound 40A. Moving on to the reaction 2. Same analysis was used to analyze the product for the reaction 2. There are two products formed in this reaction. From the FTIR spectrum, there are 4 functional groups can be obtained in the first spectrum. Firstly is C bond to H for the aromatic ring, C double bond C for the aromatic ring, C double bond O to the ketone, C bond to Cl2 for the halogen compound. The compound, namely compound 41A, obtained was in oil state with 0.3614 gram and 22.3% of yield. After that, same as other spectrum NMR proton analysis, two peaks formed at 8.07 ppm and 7.50 to 7.64 ppm shows a benzene ring. Another peak shows at 6.69 ppm shows that the carbon probably hold one hydrogen atom. Thus, it is predicted that there are 2 chlorine atoms at the carbon. So, the new structure compound 41 was recorded labeled as 41A. The structure of compound 41A was confirmed by using carbon NMR. For the second product of the reaction 2, the same functional group, which is C bond to H, C double bond C, C double bond O, and CCl, was found in the IR spectrum for the compound 41B. The compound 41B obtained also in oil state with 0.2386 gram and 12.55% of percent yield. However, the proton spectrum for the compound 41B is slightly different from the compound 41A. This is because from the proton analysis, only 2 peaks formed at the 8.23 ppm and 7.53 ppm to show a benzene ring. There are no peaks to show the presence of CH. So, it is assumed that 3 chlorine atoms bind to C, leave it without any H. So, new structure was formed different from the one in methodology and named as 41B. The carbon spectrum for 41B shows the same functional group as the compound 41A. However, the chemical shift for the compound 41B is slightly upfield by 114.19 ppm compared to the compound 41A, which is 67.82 ppm. Lastly, for the reaction 3, there are 4 class compounds can be found in the structure of the compound 42A, which is aromatic ring, ketone, and halogen compound. The compound 42A obtained was in white solid with 0.7473 gram and the melting point between 76 degrees Celsius to 81 degrees Celsius, and the percent yield is 39.47%. For the NMR proton analysis, 2 peaks formed at 8.05 ppm and 6.96 ppm shows a presence of a benzene ring. A peak to show at 3.86 shows that the presence of the CH. Another peak at the 6.64 shows 2 chlorine bind to C, leave it with 1 H. Thus, new structure was formed which is different from in the methodology named as compound 42A. And lastly, for the carbon NMR spectrum for compound 42A, there are 5 functional groups can be obtained. First is C double bond O, C bond to OR for the aromatic, C double bond CH for the aromatic, CH and OCH3. All the chemical shift for the compound as shown in the spectrum are shown, which confirming the structure of the compound 42A. Thus, compound 42 was not obtained. As a conclusion, the product for reaction 1 was successfully obtained with new product labeled as compound 40. However, for the reaction 2 and reaction 3, the attempted product was unsuccessfully obtained. Instead, 2 new products were furnished in each reaction, 2 in reaction 2 and 1 in reaction 3. To improve the process in the future, the time for reflux process should be reduced to increase the percent yield of the desired product. Number 2 is use different method of catalyst loading to identify the best amount. That's all from me. Thank you.